welcome back everyone. And finally we have our talk on hacking the Xbox 360 with the Raspberry Pi Pico. Please welcome Dile.
Hello. Thank you very much. Welcome to my lecture. So we will be talking about the Xbox 360, its security, the security flaws, and ultimately how we can defeat it and run basically anything we want. So first off, I'm a web developer, I'm a tinkerer, a gamer, and I've been modding consoles since I was 16, when I got my first Nintendo Wii, and it was pretty boring. I only got like 2 games, and I wanted to do something more with it. So I found out the world of modding your console to run some homebrew software, some applications that are open source, and basically anything you yourself write or anyone else on the web. So what's the deal? What's the actual deal with hacking consoles? So any console that's been manufactured by, let's say, Nintendo or Microsoft, it's got it can only run the code that the manufacturer have signed, and so it can only run a legit code. But it's my machine. I should be able to run whatever I want. So when you hack the console, you have the freedom to run anything. The only downsides to that, you will void your warranty. If you are able to modify the games that you play, you could have cheaters. And of course, it opens the door to piracy, which is something that we don't actually want. So a bit about the Xbox. It was released in 2005, and it had pretty, very powerful architecture and very powerful hardware for that period. And about its security, so it had an encrypted ROM image that you can only run stuff that were checked by the hypervisor, and it had e-fuses to prevent downgrading and running some potentially dangerous software. So what actually is a hypervisor? The whole operating system actually runs inside a virtual machine, and the hypervisor is like the observer that makes sure that everything that runs on it has been signed and checked. And there's actually a piece of code in the CPU that makes it impossible to modify the hypervisor itself. And so the developers and some hackers found out some pretty neat stuff, how we can actually defeat the hypervisor. And the first one was called the King Kong shader exploit. It was discovered just 1 year after the console's launch. It only worked on these 2 kernel versions, and it required a modified game of King Kong. So essentially you patch the game to run some modified code instead of the shader that is used for the first scene in the game. It was reported to Microsoft before actually showcasing it, just to make sure that nobody else would, that Microsoft would have enough time to patch it before somebody breaks the system. And also it required a modified DVD drive, so you can burn the game and run it from there. And it's very outdated. It only works for these 2 kernel versions, and it's not very interesting to us, but this is what it looks like. So when the game loads, it says press start to continue, and right after that you can run Linux or anything you want. Then, a few years after that, the JTAG exploit was discovered. So it essentially used the same flaw in the King Kong shader exploit, but the only difference was that it resided on the JTAG port, and it loaded an image right out of the SMC chip. So it injects the King Kong shader exploit, the payload, and it basically runs any software. It only works on dashboard 7371, which is way old. It's outdated, and it's not even possible to do that on a slim console like this. It was only present on the older consoles. And then the next development is called the reset glitch hack. So basically, when the console is booting, the image that's on the NAND, the ROM, it gets checked against a hash, a known hash that's hard-coded inside the processor. And so if somebody found out, if we listen to the postcodes when the machine is booting, and we hear a specific postcode, if we pulse the reset signal, it will reset the registers that are responsible for telling us if the image is modified or not, but it won't actually reset the whole console. So we can basically clear the error codes and continue to boot the console. So when the check passes, it returns 0 because it's been restarted, and we can run anything we want. It's actually unpatchable on consoles because it bypasses everything that has been designed by Microsoft to withstand. And actually, we needed an external glitch chip that would have all the logic for listening to the postcodes and to slow down the processor and inject the reset code. So this is what the early glitch chips looked like. So you can see there's a bunch of wires. One of them is going to the post output that is listening to the postcodes. The other one is linked to the reset signal itself. It's the one that actually pulses the reset signal. And we have some other ones, for example, I'm not really sure, I'll just go on. So something that was discovered just a year ago, we don't really need the glitch chip anymore. So we can program the SMC itself to listen to the postcodes and to do the actual reset glitch. So we don't need any external hardware. We don't need to glue anything on the board. We just need two small wires because the SMC doesn't see the post output and it doesn't see the reset signal. We just need to solder two small wires from the SMC to the CPU itself. It was discovered by the user 15432, and it looks something like this. So you just take two wires and connect it as the picture shows. This is the setup on the fat consoles, and this is the setup for the slim consoles, as you can see here. So how do we do it? We first need to apply the mod wiring. We need to read the ROM. We need to make sure that we can boot Linux on it. So we can extract the CPU key, decrypt the firstly read NAND, and then write our modified image on it. So this is the software that is used for everything. It is, I like to call it the Swiss Army knife for Xbox 360. And you can find the GitHub right here. So in order to read the NAND, you would actually need a device that's able to connect to the SPI port on the NAND RAM itself. But those are outdated because last year somebody got the genius idea of making a firmware for the Raspberry Pi Pico that essentially it makes it SPI flasher, and you can download it. You can flash it on your Raspberry Pi Pico, and you can read your NAND. You can write it. You can do anything you want. So what do we do next after we read the NAND? We can write a modified ECC image on it. So ECC is essentially just first 50 blocks of the NAND. It doesn't need to be encrypted, but it can read CPU key. It can read all the encryption information that we need. It runs this Zell Reloaded, so it's a modified Linux image. It starts the network, so you can connect your previously mentioned JRunner software to it. And as you can see right here, can you see my mouse? Yeah. So this is the CPU key that is needed to decrypt the NAND. And so while this Linux is running, it's also listening to update information. So essentially, you can even update your NAND from the software. You don't need to hook it. You don't need to hook the Raspberry Pi again in order to write the image. After you get your CPU keys, you need to input them into this program in order to decrypt the image, in order to make the completely new modified image that essentially can run unsigned code. And yeah, you just enjoy your modded Xbox like this. So this is a modified Xbox. Here I have an application that's called the XEX menu. Normally, an unmodified console wouldn't be able to see this application. It would just report some corrupted data or stuff that it can read. When you open this, you have essentially a menu to run anything you want. If I go to sorry. Technical difficulties, sorry. Okay, so what you see here is an application called the Dash Launch. Essentially, it's like a God mode application for your Xbox. It can modify the launch paths, so anything that you don't need to boot inside the Xbox dashboard. You can boot to anything you want. You can set your own application to run from it. For example, this is a modified dashboard that's called the Aurora. It contains a modified dashboard with file manager, with system settings. Essentially, you have the control of your whole system. And just to demonstrate another neat thing that you can do. You can't really hear it, but I can override the fan speed, and for example, if my console is overheating, I can just keep it cooler. And from this menu, I can also launch any other executable that I want. So basically, that's it for the modified system. So, what was the point of all this? So when you own a console, you should be able to run anything you want. That was the whole point of modifying the console. So Microsoft, they actually realized that if we give enough freedom to developers to run their own software, we wouldn't have that many people trying to break it and open the door to piracy and stuff like that. So when they released the Xbox One and also the newer Xbox Series S, they have developer mode. It's like a one-time payment that enables you to have essentially a software development kit on your legit console. So they and it showed that it was actually a very smart idea, because nobody then tried to modify the Xbox One, because you essentially you have the freedom to run whatever you want. And even for the Xbox 360, the newest revision of the motherboard, so-called Winchester, it has a hardware patch for the reset glitch hack, because you can't really pulse the reset. It gets latched, so it disables the whole hack. So the latest version of the Xbox 360 and the Xbox One are not vulnerable to this hack. And so that would be it. Questions? Thank you.
I have a question, if I can. Have you tried overclocking your 360?
I'm not sure it's possible. I mean, it can be, but it's not really something that's useful, because the hardware itself is powerful enough to run everything that has been written for it. So maybe someone tried, but I'm not sure.
Okay, thank you.
I actually own a modded 360 as well, and I see a lot of, same goes for the PS3, being used for emulation and stuff. How do you look at it using for things like that in regards to power draw and efficiency towards a NOC or something more modern, which you can use for the same purpose with a lower wattage? Do you still see a business case for using a 360, for example?
Well, yes, of course. So you can, when you have a modified system, you can emulate software, like you said. It doesn't really matter if it's a PlayStation 3, if it's an Xbox 360. So your main concern is the power draw of the
yeah, for example, you could replace it with a more modern NOC, whatever, and achieve the same result with more efficient hardware, in my opinion. But I'm curious to how you look at it.
Well, I can agree with your point, but for example, if I only have an old Xbox that's lying around and it's not doing anything but collecting dust, why not? Why not just modify it and be able to run whatever you want?
Fair enough. Yeah.
Any more questions?
you very much.